We did this part already, didn't we?
No.
No.
Oh, we
This is
didn't?
5.
Yeah,
No, we
we
didn't
got
touch
up to
5 yet.
We didn't touch 5.
Got it. Okay, maybe my. All right. So number 5. It says find the intervals where the function is increasing. So the function here is increasing every time the derivative is what?
Greater than
Above
0.
0.
Greater than 0. So here and here. My thing's lagging a little bit, if you can tell. And it's decreasing anywhere the derivative is less than 0. Good. So let's assume negative infinity to 2, and then 4 to positive infinity. And then it's decreasing from 4 to
It'll be 6.
6.
2 to 6. No, it'll be 6 to positive. 2 to 6, not 4 to 6. No, 6 to positive infinity for increase.
Oh, yeah, I don't know why I put a 4 there.
4
I know.
6.
I don't know. I've been dealing with that on a lot of numbers lately, you know. Math teacher things. I just wrote a 4 again.
Oh my gosh.
Sorry.
6. Yeah.
Sometimes I get a number in my head and I'm just like, you must write that number. And it's the only thing in my head. Okay. Hopefully that makes sense. That's what the regions match, right? So it says find where the local maximum and minimum occur. So
It transfers from
a minimum occurs when we change from
positive to negative. No, negative. Yeah,
Positive.
positive, negative. Yeah.
no.
Oh, wait.
That's a
Wait.
That's some
Max.
that's a
maximum,
max, yeah. We
right?
have it backwards.
We have it backwards. I draw it out every time. Just makes more sense in my head. So yeah,
It always throws me off when you have it like opposites.
that's a minimum.
Yeah.
So in this case, a minimum is going to be right here, right? Negative to positive
6.
at 6. And then we have a maximum at
2.
x equals 2. Cool. Okay. Now it says to identify concavity. How does concavity relate to the first derivative?
It's when it changes from increasing like in y value to decreasing in y value.
That's true, yeah. So exactly, concavity is the slope of the first derivative, right? It's basically based around the slope. So everywhere that the slope of this is positive, it's concave up. So it's going to have a positive slope from negative infinity until we get to what?
1.
Good. And then from where?
Is it 4?
Mm-hmm.
4 to positive infinity.
No, 1 to 4. Yeah. Yeah, but
And then concave down from
1 to 4.
1 to 4.
Yeah.
Okay. And then what's a POI?
A person of interest.
Point of interest.
Point of inflection. It's where we changed our concavity, right? So where did our concavity change?
1 and 4.
Good. So now we're going to use some of the information that we just developed to do a general sketch. Okay, think of this as like your police sketch, okay? We don't know if it's exact, it's just going to give you an idea, okay? Yeah.
Wait, so this is just like you take the information from the first derivative and you draw a sketch of the second derivative?
We're actually drawing a sketch of what we think the
Of
function.
the original.
Yeah.
Okay.
So we're using bits and pieces of information given to us to try to figure out what this function once looked like before we took the derivative of it, which
Okay.
is hard because we're missing some information. So we have to go through about what we know.
Yeah, this kind of stinks.
It's tough. So here's the way that I find it to be the most simplistic, okay? I know that this graph is going to be concave up, right, from negative infinity to 1. I'm just going to copy it over because I don't have it on the same sheet like you guys do. And then from where?
4 to positive infinity.
Good. Where's it concave down?
1 to 4.
And that's the only place?
Yeah.
Yep.
Okay. And then in addition to that, I know that everywhere here my slope is positive, my slope is negative, and my slope is positive. But that part we can actually figure out by looking at the graph. Now I also know that I have a maximum at what value? X equals 1. And then I have a, was it at 1?
Wait.
No, guys, max and min.
Max is at
Wait, what? Oh, wait.
2. Was it 2?
What I'm asking, I'm just asking you guys to read it.
Max is at 2.
Yeah, max is at 2, minimum is 3 hours.
Thank you. Sorry.
Because we're going based off of the info we had before.
Yeah, I just don't have it on the sheet, so I was just.
I forgot there's another.
No, it's okay.
It's
That's-
4,
yeah,
not
exactly.
6.
I thought it was 6.
Is it 6?
It should be
That's
right.
right. Man, now I got 4 stuck in my head.
Oh my gosh. I saw it going down.
Oh, no.
I think you said 4.
I did. Yes, I corrected myself. I'm sorry. I said 4 like a long time ago. Okay. Anyways.
We're all going down.
So, what we're gonna do is let's think about this logically. So, we know that the graph of the derivative is where basically each y value is the original slope of the graph, correct? That's how you graph a derivative. So what we're gonna do is we're gonna look at each point on this graph,
Oh, what the hell?
and we're going to look at what the y value is. Okay, so we got 1, we got 2. You're just estimating here, so don't get too out of control.
I was about to say.
So, when we have x equals -2, okay, we're going to make a little like chart almost. And this is going to be our slope. So our point with our slope.
Wait, shouldn't. Never mind.
You're gonna make us all confused.
We're all, there's nothing but being confused about this topic. There's no way to do it without being confused.
Yeah,
I
it's-
watched about 100 YouTube videos on this, and none of them were any less confusing than the other. So trust me, I tried to make it the least amount of confusing. Here, what would be the y coordinate there?
Like 0.5.
So what that's saying is that's what the slope of the original function is at that point. Okay, that's the easiest way I can think to explain it to you. At -2 or -1, what is the about y value here?
1.
Yeah, we're gonna say about 0.75. It's a little less than 1. You want to be as precise as possible. What about at 0? What is our y value?
1.5.
1.5. Good. What about at 1?
2.5.
2.5. What about at 2?
0.
Good. So 2 is 0. That means that your slope is going to be 0. So we know that the graph at that point is going to, yeah. And we also know at 2 it happens to be a maximum, which makes sense, right? We know that oftentimes when we have a maximum in, the slope goes to 0. What about at 3?
-2. What,
Yep.
Negative, yeah.
-2. That's good. What about at 4?
Negative 2.25.
2.25. Okay. What about at 5?
-2.
Good. What about at 6?
0.
Good. And then let's estimate 7.
Like 1.5. No, that's like a
Like 3.25.
Okay, we're gonna go with 3.
I ran
So-
out of space.
What we've just come up
We're
with
it for a while.
right now is we're basically just now finding what the slope is at each one of these points, and then we're gonna go with the other information that we know and try to bring it all together. So what I like to do first is I'm gonna basically draw in a bunch of little tangent lines, okay, as indicating the slope, and then I'm gonna trace my curve over it. That's the easiest way I can think to do it. So at -2, my slope is 0.5. Now keep in mind, if I have -2 and I have a slope of 0.5, that could be up here, that could be down here. All it's telling me is my slope is 0.5. So you have the freedom to choose where you're going to start this thing, because they didn't tell me to start at some value. Okay, so I'm just going to start low, because I know I'm going to probably come up from that, because I mostly have positive slopes. So I know my graph's going to mostly be going up, so I want to give myself enough room. Okay, so at -2, my slope is about 0.5. So it's pretty mellow slope. Okay, so something like that. What happens when I get to -1?
It picks up slightly.
Picks up a little bit. Yep. What about at 0?
It's pretty steep.
Yeah, it almost doubles in steep. Well, actually, it technically exactly doubles in steepness, right? What about at regular 1?
Increases even more.
Increases even more, right?
Uh-huh.
What about at 2?
It just doesn't
Zero.
raise at all. Yeah, it goes
It goes flat. What about at 3?
Down.
goes
Down.
down.
Goes down. What about at 4?
Down.
Keeps going down faster.
Down a little faster. What about at 5?
Down,
but a little less steep.
no,
I kind of like went a little too, yeah. And then what about at 6?
it just flattens
It's
out.
0.
Flattens out. And then what does it do when it gets around 7?
Shoots up.
It shoots up.
Shoots up. Okay.
That's
So
a
that's
crazy graph.
My general sketch. Now we're gonna go in and kind of throw in the concavity aspect. Bless you.
I didn't follow. Mine was similar, right?
No, it doesn't. No, you're going up. Like,
Bro, what the hell?
I don't know what you're doing.
So, we're gonna throw in the concavity aspect, and we know we have a max and a min. Ours kind of looks like we do have a max and a min about here, right? So we kind of nailed that part. So concavity. This graph has to be concave up. Concave up when it's less than 1 and greater than 4, correct? And then my graph is concave down when it's between 1 and 4. So I'm going to try to add that aspect in when I go to do my actual sketch. Okay, bless you. So here it's concave up. Everybody see that?
Mm-hmm.
And then when I get to 1 or 2, it flattens out. And then it becomes concave down. So concave down, keep in mind, it has to change its inflection a little bit to look like it's concave down. So it's gonna go like this, okay? Concave down. And then what's it gonna do here? It's gonna flip to concave up. And that's how you get a sketch, a general sketch, okay, of your graph.
That's a stupid graph.
Yeah, this is gonna be on the test.
at all.
No,
Why does it look so similar to the?
that happens a lot actually. So, keep in mind though, if we change from concave up to concave down, this almost has that appearance that it shifts, okay, the best you can. Now I want to you all keep in mind, I'm not going to have you do one of these on the homework the best you can. I would not ask you to do this on the test, okay? I just want to make sure we go through it and you have a general understanding of how the two relate to each other better now. Did everybody see how we threw the tangent lines in? We gave a general sketch, okay? So, everything else on the homework except for number 5 is something I would ask you on a quiz or a test. But number 5 is tricky. Try your best.